So Brian,
Yes.
CSI Division 27 is now providing power and data to end devices. Can you just describe how
Yes.
communications has evolved and the Division 27 communication cable is actually empowering smart buildings?
It is. It's a key part for sure. So another acronym comes up, right? PoE, right? Capital P, little O, big E. I see it misused a lot.
Yeah.
So yes, it definitely is. So if I think back to 2001 timeframe, 2001, 2002, off the top of my head, Bixie held a conference in Seattle. So at that time, I did a presentation on the main stage talking about PoE, and that's when it first came out.
Yeah.
But back then, it was 15 watts of power that could be delivered to a device over the network cable, right? So the whole topology is in place to do that.
Right.
And back then, it was a big deal,
Yeah.
right? What happened? Now we got power, and I got data on the same cable. How is that going to interact? Is the data going to be corrupted? Which pairs is it on? All those things, but it's a frequency based, so there's no interaction at all. It's like lanes of the highways that are way far apart.
Yeah.
So data gets through just fine. Your power makes it through. So we're going back 2001. Now we're 2019, 18 years, right? 15 watts.
And the evolution
was
of
big.
technology, yeah.
Right, but now instead of plugging into a wall, which usually they're going to be those bricks, right? They're going to be those ugly bricks, and you got to go from AC to DC.
Yeah.
Because all these components are mainly DC.
Right.
But now we can use a switch, a Cisco switch or any type of network switch to deliver the data and power at the same time. But that's going back 18 years now when they first started doing that.
Wow.
It's all over network cable.
Where are they now? So 15 watts power. There's some new standards that are recently released that are allowing significantly more power and data to the end device, which allows for more on the network, right? So can you just describe a little bit more about that?
Yeah, definitely. And that's a whole progression. We want to do more with it, right? So that switch port's given the network Ethernet. It's given all the ports wireless, all the different applications. Now, at the same time, we want to do the power. So now we're going for 15 watts. It was within 3 or 4 years, we went to 30 watts.
Okay.
You're doubling your power, right?
Yeah.
And now just the standard just came out, the IEEE 802.3 BT just came out.
Yeah.
And now they jumped to a type 4 power, which is 60 watts. Now we're doubling again, right?
Yeah.
So it looks like, and then we got type 4, which is 90 watts. So it's a 30 watt progression in each cross to do that.
So it's still low voltage.
So low voltage, DC voltage, frequency based.
Okay. And what kind of devices can be powered and provided data at 15 watts versus then this 90 watts? It's completely changing the game, right?
Oh, it is, right? Because it started back in 2001, too. Simple cameras, access control to a room, simple things that required 4, 5, 10 watts. Wireless access points, pretty basic. They were pretty easy. So we had a very select, small group of things that could work on it.
Yeah.
So if we go to 30 watts, now we can do more outdoor cameras. Some of those applications that might have motors or heaters in them that draw more power. And then going to 60 watts means that we can do even more, 90 watts.
Yeah.
TVs, screens, any type of a DC motor.
Yeah.
And that's why lights are such a thing that we can do over them now.
I'm seeing that transition from where I sit in terms of sustainability because solar panels output DC power. The lack of conversion necessary then to go into AC is a wonderful application of how you can apply this smart building system actually from solar panels. So I do see that transition happening quite often in the
That's
in
the ultimate,
market.
right?
Right.
Harnessing the power of the sun, renewable
Net
energy.
zero energy, yeah.
Bring it right through
Using
the building.
what you make out of solar, yeah.
So there's a lot of folks that talk, they say, why convert it? Why are we taking power, converting it to AC, generating power in the AC, bringing it, transmitting it to a building space, converting it to DC, to convert it back to AC to DC again?
Yes.
So all these conversions require energy, and there's energy loss and heat and those type of things, so it's not efficient. But if I can bring DC throughout the whole progress from where it starts is generated all the way to the end user or devices like lights or anything, then yes, you're going to get a very efficient system that's renewable throughout the whole thing.